I've started recording before I forget. I guess we'll give it at least until 9:05. A couple more people just joined. So good morning to those who just joined. We'll get started in a little bit. We'll just see if any more people remember to join before we get started.
I agree with the music. the dead silence is awkward.
Well, it's 9:06. Amy, you want to get started?
Yeah, are you all ready? All right. So hello, everyone. Welcome to the first Elevate conference. We are super happy to have you all here. So just a little bit of background behind kind of why we're having this conference today is that the four of us are involved in a program called the SELF program. And the purpose of this program is to develop engineering and computer science graduates that have kind of a knack for the business side of things as well. So at the end of the 4 years in the program, since it's a 4-year fellowship, all students develop a project, a year-long project called a capstone. And that capstone is centered around giving back to the community and involving all the pillars that include interpersonal skills, management, leadership, and business skills. So that's just kind of the reason why we're here today. And so a little bit more about our capstone and why the four of us chose to do a conference. So the first part of the capstone was to introduce high schoolers from underprivileged schools in the Kansas City metro area to the possibilities of what a degree and career in engineering would look like. And that part was completed in October by completing a call during high school design and talking to students and doing a panel. Now, the second part of our capstone is to provide teachers with supplies to teach students hardware and software concepts to further STEM education in the classroom. However, when we first started planning our capstone about a year ago, we did not expect it to be virtual. So when we wanted to include the hardware, we were going to be in person and everyone would have the hardware to touch and actually do the projects with, the lessons with. But we still think that that's a really important concept of the engineering school and of computer science and computer engineering. So today we're going to still do those lessons. However, the hardware will be sent to all the teachers at the end of the conference. So we will be mailing either the Makey or the Arduino to all of the teachers afterwards. So just a little bit about us. So Linda, if you want to start off.
Hi, everyone. Thank you for joining this morning. I am Linda. I am studying engineering physics at the University of Kansas. I will be graduating in May. My concentration is a hybrid between computer engineering and electrical engineering. And we actually do a lot of work with hardware, not as much with software, but I will be leading your hardware session today, and I look forward to working with all of you. Joey?
Hi everyone, my name is Joey Pennington. I'm a senior from Shawnee, Kansas, studying interdisciplinary computing with a focus in biology. And the IC program is a relatively new form of the computer science degree that is sort of like a major and minor in one, with your major in computer science and your minor in one of 6 different natural science disciplines. So if any of your students have sort of interest in both technology and computing, as well as things like biology, chemistry, physics, even geography or journalism, this is definitely a great program for them.
Hi everyone, my name is sorry. Hi, my name is Antoinette Gishohu. I am a senior from Overland Park, Kansas. I'm actually studying computer science. Forgot to fix that on the slide. Yeah, I'll be leading the software session today, and yeah, looking forward to it.
Hi, everyone. My name is Amy Lusler, and I'm a senior in computer engineering, and I'm originally from Olathe, Kansas. And computer engineering is a combination of hardware and software in the system as a whole, and understanding how your hardware components like your keyboard are working with your software and how the two integrate together. All right, so the next part of our conference will be just kind of deciding if you all want to go to the Makey lesson or the Arduino lesson. So both lessons will take place after the software lesson. However, to start thinking about which one you may want to go to, which breakout lesson, the Makey is on the left, and it uses closed feedback loops to actually connect like your keypad to different objects, everyday objects, whether that's bananas or cans or whatever else. You can control games and you can code basically whatever to go along with the Makey. And on the right is the Arduino. This is a more advanced hardware lesson. You can do a lot of things with the Arduino. It includes a breadboard, the Arduino, and a lot of different electrical components like resistors, capacitors, transistors, buzzers, and LEDs. So if this is something that for probably older students of how to actually connect the breadboard to the Arduino, but it is more like what we would use in industry. So for like our other senior design projects, we are using things such as the breadboard and the Arduino. So if that's something you're interested, that might be the lesson you attend. So then for the last part of our day, right before we do our closing remarks, we are going to be joined by Microsoft Teals. And Teals is a program that aims to introduce more students into the STEM field. They are all about supporting students and increasing inclusivity, empowering volunteers, and helping teachers actually teach computer science lessons to make them more independent in the classroom and feel more confident in teaching STEM lessons. So we will be joined by Haroon at the end of closer to the end of the conference today. And if you want to know more information, their website is microsoftteals.com. And you can kind of do more research and actually, if you know of a good volunteer, they can apply through this website. Or if you want to become a Microsoft Teals school, this is also the place to do that. So just once again, to show everyone kind of what we're planning on doing for the rest of the time of our conference, here is the first part. We are currently in the opening and transition section. And we'll probably move to the next section a little bit early. And then we might end up a little bit earlier too, or just have longer breaks, just kind of however we feel at the end of each session. Some of them are a little bit longer and a little bit more involved. So we may have more breaks at the end since everything in the schedule is back to back. So we'll probably have 10 to 15 minute breaks after every section. So the first session will be with Antoinette, and everyone will be attending the same session. And then the next session will be where you join the breakout rooms, either Makey or Arduino, and you can choose between the two. And then after that, we will go into the Microsoft Teals, and then we will have the closing remarks and end for the day. All right, so Antoinette, if you want to go ahead and get started, yeah.
Yeah, let me get set up really quick. Okay. So I found out last night that if you do a PowerPoint presentation. You can't really do like link sharing. So we're gonna do this version of PowerPoint presentation, and we're gonna split screen it. Hopefully no one is bothered by it, because it is a lot of links, because I want to give out as many resources as I've been able to gather throughout my time in like computer science and computer science like education. So this is the software education resources portion of the conference. So yeah, let's just get started. So just a little bit of background about me. So my name is Antoinette Shohu. I'm a computer science major graduating in May. And I do a lot of outreach for my role. I'm the Women in Computing Outreach Chair, and we're in charge of Girl Code, which is introducing computer programming to 5th to 9th grade aged girls. And we do, previously, when we did it in person, we did stuff with Raspberry Pis, and now we do stuff with Hour of Code, now that it's virtual. I was also in charge of Engineering Expo. If any of you made it, Women in Computing had the Minecraft room where we did snap coding with a couple hundred students, I think. So through this role, I've gotten to gather a lot of resources for doing technological education to younger students. I mean, I wouldn't say I'm like the authority on it or anything, but I've found a couple of things really helpful. So I'm here to share that with you all. So for teaching computer science, I think there's like 3 main facets to give you like a pretty good, well-rounded view of programming. The first is snap coding, which is like Scratch, Hour of Code, etc. These are everywhere, and it's very easy to learn. The second one is logic, so like Python, C++, Java, all the languages. And the third is web development, like HTML, CSS, JavaScript, and then there's like the encompassing ones, React, React Native, Angular. But so I'll be going into more detail about these, but these are the main things I think kind of give a good introduction and a good understanding of like what it is computer scientists do. So let's start with snap coding. So for snap coding, there's a lot of resources. One of my favorite ones is Hour of Code, and I don't know if you've already been introduced to Hour of Code, but it's really cool. This is from Google for Education, and I like this one a lot, especially if you're like a teacher handling an entire classroom, whereas I was just like, you know, handling like 10 to 20 girls, and they were only with me for like a Saturday. So what I like about them is that they give you materials on how to get started, especially so if you use Google Classroom, they give you like step-by-step instructions on how to set it up. And if you don't use Google Classroom, you could have your students come in with their own Google accounts. And they give you a suggested class structure, they give you the videos. They give you a lot of resources on how to get started. They give you like a script on what to say to your students as you're teaching them. But it's very neat, and I like using it for Girl Code purposes. Another thing that they do is that they give you a lesson plan, and these links will be shared after the conference in a Google Drive. But so they give you this lesson plan that goes over like, you know, like what the project is, an example project, some tips, and, you know, learning objectives, grade structures. And for this, it's not, I don't think that it's like a grade thing. Like I said on this part, I think it's just mostly targeted for beginners, because like I'm a senior in college studying computer science, and there's 13-year-olds who can do way more with computer science than I could. So I wouldn't like stick this like a third grader. Like if you're just new, just do it. Like it's such a good way to like pick up logic. But yeah, they have like the recommended grades, I guess. And they have a lesson plan, a procedure, a setup, transitions, times. It's such a good resource for teaching kids how to get started with logic. So they also give you examples on how it runs. And the audio doesn't work from my computer, but we'll just watch this really quick. Yeah, so that was something that was coded, not really sure by a student or not, but it's a really good example of what to do. So when you get to the lesson, start it, and then they have some videos for you to show the students. And then you have a starter project link somewhere here. That's fun. So I sign in as a teacher because it's, I think, easier that way. But the one we were doing is dialogue. Yeah, so then you get a lot. It's kind of like an overwhelming amount of options. So what I like to do is limit it. Like I would show the students what we're trying to do. So this is Sprite 1, Sprite 2. We're just gonna start simple. Let's make them say hello to each other. So then we teach them about like fire off events. Like these are the options that start the program, and you can tell because there's no like block to connect to, like there's no way to connect to another block from these. The typical one that's used is when flag clicked. And then, yeah, there's these, so this has to do with motion. It's like moving, turning, going, gliding, pointing, changing, and setting your X and Y's to like make the character like shift quickly. And then there's looks, which is like just speaking, switching costumes, changing size, changing color, setting color effects, and the backdrop. And then there's sounds, which can be very fun because sometimes people will make it go forever. And we didn't know how to stop it when that happened the first time, but it was fun to discover. And then there's events that trigger like the program starting. And then there's controls. This is a very good way to teach them like loops, if statements, and repeats. And then there's the conditionals to the if statements and the loops. I think they are limited to this. And then there's moving around, some operators, and then these are more conditionals for the loops. And yeah, so I usually start off simply like the first person says hello. And then the most important part, at least for this one, for this dialogue creator, is making sure that like you're creating like a suitable dialogue so you don't both say hello at the same time. Like because the other character said hello for 2 seconds, we have this one wait for 2 seconds and then say hello. So yeah, it's fairly simple, but can get like, you can get like some really cool dialogues, conversations, every other kind of program hour of code they have. We can go through what they have in their curriculum. There's characterization, interactive presentation, dialogue, narration, figurative language, CS First Unplugged, I'm not sure what that one is, Code Your Hero, and then there's those that take multiple days, storytelling, music and sound. There's the intermediate level. Yeah, so it's all really, really cool. And what I like about it is that it's free, and you don't really even have to guide them all that much. It's something that they can pick up after a couple of examples and explore themselves. But yeah, this is something that I found super helpful and very useful. So the next one is, I'm going to close all of these because they get kind of overwhelming. The next one is Scratch, which is the exact same thing we just did. But this is like a good example of like the potential that it has. This is just, it's just a bunch of clouds moving, but yeah. So it's an infinite loop of just clouds moving through the sky, which from the blank thing you saw, like, you know, how does one think of that? But I think that's part of the fun of it all. It's just you get to explore so much, and your kids can make something super cool that you would have never been able to see. But yeah, this is the code that goes with it. I think every single cloud has the same code. It's really fun because it's just a lot of random stuff, creating clones. It uses loops, it uses the goto. But yeah, there's that. And then the thumbnail that comes up originally is like immediately hidden. This is a really cool example of what's possible with snap coding. So some pros, oh no, still have one more. So this is a more directed version of Hour of Code. We did this with the Expo students. It was Minecraft, and I think they thought they were going to play Minecraft, so I don't think they really enjoyed being made to code, but oh well. But it's kind of a more directed version than the CS First version. So it tells you, you know, add a second, move forward, and then you'll reach the sheep, and then you run it. Yeah, so it is a lot of snap coding where you kind of build up to a greater program. I like this because, for example, with Minecraft, like a lot of kids really like Minecraft. So it's something that they can like visualize, and hopefully gets them thinking about like, what is like, how are the games I play made? So if like gaming is something they're interested in, then maybe they'll like, it'll get their wheels turning, and they'll become more interested in like coding the games. Something that I really like about this is that, so the one right before this, you have to do, not this one. Before the repeat blocks, there's one where you have to do so many move forward. So it's like a really good bridge to teaching about loops, which is a very important thing. You can't just like, I guess, introduce loops. But yeah, so you see that you have to do like move forward, move forward, move forward, destroy block, turn left, move forward, move forward, move forward. So it's like exhausting, and then you get to introduce loops. And you just say repeat 4 times, move forward. What is the goal here? Placing something. yeah. So it's just something super simple. Takes an hour to do, and it's based on like a real life example. So all the pros of snap coding are that it's easy to understand, it's very visual, and there's immediate execution. So the kids can see like, I did this and the result was this, which I think is very fun, especially if you're just getting into building programs. Some cons is that once you get used to it, you get really uninterested. Like I remember in our expo room, we had some kids who'd already done it before, and they were just not having a great time. But that's when we come into, wait, really quick, does anyone have any questions? I see there's something in the chat. Yeah, thank you, Serena. Any questions? Cool. Okay, so if they get bored of snap coding, that's when we get into logic. So logic is just writing the code, and there's so many resources. So one of my favorites is Python. Python is pretty simple to understand and pick up, and it's really simple to like find resources online. And it has online compilers, which is great because sometimes installing stuff is so complicated for no reason. But if you can just run the code online, that works too. So these are some instructions we have set up for teaching Python. Yeah, so this is like teaching conditional statements. Conditional statements are fairly easy to start someone on because they read like a sentence, like you do conditional statements in your everyday life. So this is like one of our modules. We'll send this file to you after the conference. But so this is like the task. We have you get 2 numbers from the user and print them. You can get 3 strings from the user and print them, and get 1 number and 1 string and print them. Yeah, so, oh, this is like the beforehand. But so, yeah, teaching if else statements is really easy, as I said. So an if block executes certain code if a certain Boolean conditions are met, like if it's true, can you do it? If it's false, don't do it. The else if block comes in if that doesn't work, and its condition is true, and then the else block is kind of a catch-all. But yeah, so we just give out instructions on what to do and a background on the conditional statements. Yeah, so like by then, according to this plan, they should already know how to get numbers from the terminal, strings from the terminal. So yeah, so input, give me an integer, and then you cast it to an integer. And then if x equals 7, you print that, you input the number 7, else you input the number 9. Yeah. So this is just like a fairly simple just lesson plan on how to go through if statements. And then after, I mean, you could definitely build on it. And then we go through like and or is not an in. It's like just compiling what's it called? Concatenating, I guess. Just building a more complex conditional block. So it's like if 1 + 1 equals true, and 3 - 2 equals 1, and 4 mod 2 equals 0. So it's just, yeah, making it more complex and more involved. But yeah, this is also a really good way to teach like simple logic. Like these are like the building blocks of computer science. Like and or is not, and in is just like the building blocks of logic. But yeah, that's all in here. And then you get some practice problems and some application problems. Yeah, so we can actually even do one of these practice problems on an online IDE. So yeah, this is just a simple practice problem. I'm not exactly sure how to put in. Oh, that's pretty easy. So input. So our task is to get a word from the user, which we're doing in this line. And if the word is code, print out you win. So, yeah, so this is something I really like about Python is that it's not too hard to pick up. It's this is all things you could like very easily just look up, like how to take input from Python would give you that exact line of code. How to turn something to a string would give you that second line of code. And then this PDF goes over like how to do this part. And the other PDFs actually even go over how to do this part. But because it has such incredible online resources, you'll never have to like struggle to find some basic educational stuff. So if we give it code, we win. But yeah, that's some Python stuff that I think is super useful. Cool. So next we have Raspberry Pi. A Raspberry Pi is a small computer that plugs into a monitor. And it runs like a regular computer, but it's kind of built with the intention of coding on it. And they have, this is what we used to do for Girl Code pre-COVID when we were in person. We would just connect them to one of the TVs in our engineering classrooms, and we would code with the girls at using the Raspberry Pi. So they have a lot of projects, and they have like a learn at home. They have a guide for parents. They have like a learn to code with us. And then there's projects for the students, which also cover the exact three facets of computer science that I think are important. So we used to do a lot of Python code with the students. So it goes over step by step, like what you're gonna need, what you're gonna learn, and additional information for educators. They have a printer-friendly version. So this is like the goal of what you're gonna make. So what year were you born? Okay. Serena, I just saw your question on the chat. Teaching the code vocab in a meaningful way. So like, what do you mean by code vocab?
maybe like just the very like software specific vocabulary, like the loops or like if else, things like that.
Yeah.
Is that what you
Oh,
mean?
Yeah.
Sorry, I lost my buttons for a second. And I don't mean to take over. I just was. I've
Oh, you're
looked
good. That's
and
it's supposed to be
I'm looking
interactive.
expand, past the block code, which is where we've been for the last
Yeah.
year or so, and more elementaries are doing it. So we're getting
Mhm.
that on board with this, which is why I was so excited about this conference today. But
Mhm.
when I introduced Python to them with just a real simple lesson, the concept of a string was like, they couldn't, like, just some of what I thought. I mean, I took them back even into some Java to hope to
Mhm.
draw with them to get them used to that typing logic. And
Yeah.
like just fill versus stroke, we were caught there for a day trying to understand the difference between it. And I didn't know if that is a normal thing.
Yeah.
My kids are like, we use these common words, but they're not applied in the same way that they're applied in normal vocabulary. So there's a
Yeah.
disconnect between what their brain knows and what I want them to use it for. Is that making sense?
Yeah. Yeah. I
And
totally get it.
There was a resource out there to help me get the vocab quickly and easily so that we can move into the logic faster.
Yeah.
That's my thought
Um
out there. Sorry.
no, you're good. You're good. So I think there has to be at least like a like fun educational video like teaching strings students. Because I know there's go on, sorry.
I won't disrail, and you and I maybe could open a conversation later on since you've worked with,
Yeah.
sounds like my age range. So this doesn't need to be where we're going. I'm not starting a bunny trail at all. But
Yeah.
that's where I am with the moving on to the logic part.
Okay.
One, the resources that you're putting in front of my face are very exciting as far as the websites. But sorry, continue.
Yeah, no, that's totally fine. So yeah, I totally understand. And it can be hard to get kids like excited about stuff, especially if it's not, something they're used to seeing every day. Because even me, like right now, like if in my complicated classes, like where we have to like build a compiler, I don't really see the vision. I don't understand like why we're doing what we're doing. So it can be hard. But yeah, I can look up some stuff because there's a lot of like fun videos. Like I remember we found like a conditional statement rap, and I think that really got kids going about it. So I will try and find some of those videos again, and I can send it out with the materials.
Thank you so very much.
So for this Raspberry Pi stuff, this is like the program you're supposed to complete. I guess it just tells you how old I will be in 2025. Yeah, then it goes through like exactly what you'll need: a computer. And it can be completed on a web browser, so you might not even need a Raspberry Pi to do it. And yeah, it basically just goes step by step, like exactly what you're gonna need to do, and then what the result is, and then it gives you challenges after. So this is a really cool resource for getting kids to code. And Raspberry Pis are fairly affordable, but I think it's like $50 for like a really, really good one, and they last basically forever. But yeah, that is our second logic resource. As we saw, they also have Scratch and web dev stuff to work with. So really good resource for students. So C++ and other like languages are for anyone who's like particularly really excited. They picked up Python pretty easily and all that, but C++ can be fairly complicated, and like I'm only really good at like C++ and Python, so I can't speak to other languages. But this is just more for students who are really, really excited about it, and they think that they can like take it on, because it can be complicated to get on your computer, and the object orientation can tend to throw people off. But there's again, a lot of online resources for it. And so for logic, some pros are that it's written code. It's like actually applying logic to a program. And if your students were really excited about the scratch coding and they want to kind of get with it, get advanced with it, this could be something super exciting for them. But the cons are it's easy to get stuck and it can't get complex. And like Serena said, it's just like sometimes you can't really see like why you're doing what you're doing. It's not as visual as the snap coding. So when something happens, you're just like, okay, like we printed something. It's not really as exciting. And I think it takes a while for it to get visual. Like you can add graphics to it, but that's like a graduate student course at our school. So I don't know if I would like recommend it for younger age groups, but yeah, so that's logic. And the next part is web development. Web development is just HTML, CSS, and JavaScript. And then there's those that take on all three to make it somewhat easier. That's like React, React Native, Angular. There's more I'm forgetting, but yeah. So for these, we have slides to show. We have like intro into web dev. So we go over like what web development is, and you know how it comes about. I like web development because everyone's been to a website, and I remember when I was learning HTML and I saw like when I clicked something, it turned like I wrote this code, I clicked something and it turned purple. I was like, wow, that's what the websites do. So it felt really cool. I felt like I was, you know, in it all. But yeah, so we go through like what web development is, HTML, teaching them kind of like what it is, how it came about, and what it does. We also have a video that is very fun. HTML connects with CSS, and we also have these example websites. So this is with our friend Zach Kolfong-Patana, a fellow. And he built this website himself. So it's like a really cool way to show what you could do. So this is like JavaScript at work. The green stuff is CSS at work. And the words are HTML at work. So it's like a really, really cool demo of what web development can do. He goes into like what's basically a resume, but this is a really, really cool website. But yeah, so then we continue going through like, you know, JavaScript, which is just like the logic of the internet, some more videos, etc. But yeah, so these are just slides for teaching HTML. We have one for CSS. We have two actually for CSS and JavaScript because there's a lot to them. And I think it's kind of best to kind of introduce it slowly because I remember getting really overwhelmed by the amount of options. With CSS especially, it's like, how do you make like, you know, green look good with blue? And like there's like the color selectors and all of that. So we try to take them through it slowly in this presentation. We just tell them like, hey, this changes color, this is a tag, this changes like your H1 block, which they learned about in the HTML slides, changing background color, fonts, IDs, etc. But this is one of the two presentations that we have for CSS. And
just a quick note, sorry, on this presentation, I just wanted to say that it's not required to have a server at all for the website. You can mock up the website through just a text editor.
Oh yes, that is one of the cool things about web development that I do like. It's like you don't need to download anything. It's just like an understanding of file systems. So like when your computer sees a .html, it automatically opens it in a browser and it knows to connect the files that are in its style tag and JavaScript tag. But yeah, yeah. Yeah, so JavaScript is just like the brain of the web. It's like the logic behind websites. It's really cool. So we go through this, again, describing what it is, and then we go through logic, again, which if your students aren't comfortable with it, you can just do the HTML, CSS thing. That could still be super fun. But yeah, this is just like on Zach's website, how things were like moving and transitioning. That's what JavaScript does. It could be more of like an advanced thing for your students, but it is just logical. This is a lot like what Python is doing. There's printing, yeah, putting it all together. But we also have 2 of these, which we will send after the conference. And then there's more resources in the PowerPoint presentations. So yeah, some pros about web development is that it's also pretty visual in nature. You write a line of code, you like open it in a file and it's there. And it does include some logic, especially if you're using like JavaScript. So it's like a good combination of visual and logic. Some cons is that it can be like hard to understand how the files are working with each other. So you can have like all of it in one like file, but like good practices, like you have your CSS file, you have your HTML file and your JavaScript file, and they connect together. But there's a lot of resources to help people understand how HTML is working with JavaScript, how CSS is working with JavaScript, how HTML is working with CSS. But yeah, that's something that I found that people can get stuck on when they're working. But yeah, I think that's all the stuff I had. Are there any questions? Cool. I'll try and add more of the like where to find how to talk to students about such and such and add them to the resource file we give you after. But all in all, like it's really cool to like, because I didn't get introduced to computer science until I was a sophomore in college. So I'm really passionate about like kind of getting the word out sooner. And that's why I do like Girl Code Expo, this, like I really want more of a computer science education earlier on, because those who did kind of get it early, my fellow Capstoneers can verify, they're so good at it. It's kind of scary to watch. They're incredible at everything every second, and they're done with things immediately, and you're stuck on like some if statement somewhere that had the wrong logic, and they look at it for 1 second, they're like, oh, there it is, and you're like, okay. But so I think all of us should be like that in the future. So that's why I wanted to partake in this capstone as well. But yeah, thanks for listening to me.
All right, thank you so much, Antoinette. And we will be sending all the resources that we used today out at the end of the conference. And then also at the end of the conference, just to kind of throw it in, we will be sending out a survey. So be looking out for that as well. And your kits also. So for the next part of our conference, we are going to be doing the Makey and Arduino lessons. But we're going to go ahead and take like a 5 to 10 minute break. And then we will join back up and we'll do lessons. So if you kind of decide what you want to do, we will go from there. The next couple of minutes. But I just wanted to let everyone know that we're actually, instead of splitting into 2 different groups, we're just going to do both lessons for everyone. So we are going to go ahead and start with the Arduino lesson, and it is a little bit upper level. However, there are still some really cool concepts that can be used for middle school students for enrichment. And then we will do the Makey after that.
Can you guys see this? Okay, cool. Give it a couple more minutes.
Just to kind of reiterate, just in case people were on their little break, we are going to go ahead and do both lessons in the main session instead of breaking up, just because both lessons are super cool and we want everyone to have both. So we're going to start with the Arduino and then we're going to move to the Makey lesson. So we're kind of break up the schedule a little bit, but that way everyone can have both lessons.
Could everyone also like put something in the chat when you're ready to go?
All right, should we get started? All right. Okay, let's do this. Okay, so we are going to start off with the Arduino lesson, a little introduction, a little bit more of an introduction. My name is Linda. I have been, exposed to engineering a little late as well, as Antoinette said previously. I went to school in Topeka, so we had, the AP program and things like that, but we didn't have a specific like engineering class or like section in our schedule. And so, I always found like science, like physics, chemistry, really interesting, but being able to apply the science to actual like real world things was really interesting to me. And I just wasn't able to do that at an early age. And so like Antoinette said, being exposed in college was really hard. I kind of felt like I was playing catch up, especially during coding and during hardware as well, since you have to kind of do both to get the hardware working right. And then it's also really cool to see the hardware kind of react to your code. So it's really, really cool. I'll be switching back and forth as well, like Antoinette did, to show you the software portion of the Arduino as well in combination with the hardware. So just kind of be patient. I don't have a dual monitor like Antoinette, so I'll be switching back and forth between screen sharing. So that might just take a little second. So let's get started. So what is an Arduino? You can see it right here in the top corner. It is an open source platform, both hardware and software. You can actually build your own Arduino board that I will touch on a little bit later. It is a programmable circuit board. It comes with a microcontroller, which is just a CPU. It's like the computer's brain, right? So when you program anything, it goes there and it tells it what to do. As well as it comes with its own software. It comes with its own software platform, and then you can write in C or C++. with the Arduino. If you are working with kids who are a little bit younger, you might want to use C, as that's a little bit of an easier version of C++. As Antoinette mentioned earlier, C++ is object-oriented. It can get a little bit complicated, but if your kids are, they've been exposed earlier, and like Antoinette said, they can do a lot of things with it. They can definitely use C++. And the Arduino is used just because it is a super easy way to code and also have things react to it. The Arduino came about because people saw that how difficult it was to both incorporate software and hardware together. You always needed a separate hardware piece, a separate software piece, and then you had to figure out how to connect them together. But with the Arduino, you only need a USB cable and then obviously a USB port for your computer. And as soon as you plug it in, it's like ready to go. You can download the IDE. You can also run the code online. I personally suggest installing the IDE shown here at the bottom. It's a really nice, clean design, I feel like. So it's really easy to read your code. It's really easy to know what to do next, which I will also touch on here on this next slide. So the components of the Arduino, the layout, it has 14 pins, as you can see here on the right, 0 through 14. It always starts at 0. That was a really hard concept for me to grasp when I was exposed to hardware, that it always starts at 0, doesn't start at 1. So make sure your kids know that. I know when you code and you have to put the pins in your code, that was always a struggle because I would always start at 1, and then I call my T over and be like, hey, it's not working. And they're like, you didn't start at 0. So there's also a resonator in the Arduino. It controls the clock inside the Arduino, which just allows it to kind of put code in order of how it will be run, and it'll kind of have a synchronization. It'll tell the code which code to run first, which code to run second, things like that. And there's also an ICSP header, which is right here, and that just allows the code, the board to be programmed without having to be removed from your computer. So as soon as you plug in that USB cable, it's good to go. It also has a power jack here. It runs on 3.3 volts or 5 volts, depending on what you're running. If it requires more power, then you plug it into the 5 volts. If it requires less, you just use the 3.3 volts. Over here is obviously your USB cable. And then there's also a reset button. If you just press the reset button, it just resets it back to factory reset. It gets ready for code and all of that. Shown here is your IDE. This little check mark button is the verify button, which is just making sure that your code is good to go. There's no errors, and it'll tell you here at the output pane, if there are any errors, it'll like flash red. You'll know it's like not working. If it's good to go, there'll be text here in this output pane that is white and just tells you how many bytes are left in your Arduino. The Arduino uses flash memory, so it can hold a lot of stuff, and flash memory is erasable, so you can reprogram the board as often as you'd like. And then over here, this forward arrow is the upload arrow, which makes your code go to the Arduino board and loads it onto there so it knows what to do. And then this kind of sketchbook button is the new button, and obviously a new file for you to write your code in. And then this one is the open button, which after you've saved any of your projects, you just open that project and the code will be shown right there. And then this is the save button. You always want to save your code. That's also been an issue. If you don't save your code and you try to verify it, it will get angry. So don't do that. The menu bar, of course, file, edit, things like that. You can use the menu bar instead of these like kind of shortcut buttons. But once you get used to it, these shortcut buttons are really helpful. And then over here is a serial monitor. So when you click the serial monitor, this new window pops up, and it'll show you anything that the Arduino is outputting from what you've coded, or you can also send data to the Arduino from the serial monitor, which I will be showing a little bit later. And then of course, here in the middle is your text editor. That's where you write all of your code, where you do all your editing, where you do all of the cool stuff that tells the Arduino what to do. So next, We have a few of the capabilities of the Arduino. Like I touched on a little bit earlier, it's extremely flexible. You use a USB cable to connect it. It uses flash memory. You can delete it. You can overwrite it. It doesn't stay. It's not hard coded into the board. So you don't have to like buy a new Arduino. You don't have to, you know, like go in there and like tinker with it to make it factory reset. You just press that reset button. It's really great. It's also a cross-platform. You can use it with Mac, you can use it with Windows, and you can also use it with Linux. So it's really easy to use. It's the same kind of screens that I've showed you before. You just plug in the USB and then you open the IDE. It's the same on all platforms, which is really nice. I know, like, I have a Windows, Amy has a Mac, our engineering like computer lab has Linux. So if it wasn't cross-platform, it'd be really difficult. I'm not sure what you all use, but it doesn't matter because Arduino has got you covered. And then, like Amy mentioned a little bit in the introduction, the electrical component capability, the set that you'll be getting, actually I have it here. It's called the Arduino Workshop Kit, and it comes with a bunch of everything that's shown in this picture here on the right. Resistors, a little breadboard. It comes with diodes, transistors, LEDs. It comes also with a little like novelty items, which is like these like push buttons here, this another buzzer here, and then also 2 tilt sensors. So those are some of the projects that I'll be showing you here in a minute. They were really cool. I know, like, when I finished it, I showed Amy and we were like amazed, and we're like seniors in college, right? So it's really cool to see it come to life. Again, the Arduino can be used for programming if you're just starting out. Really simple things. I kind of plan my projects starting from really simple and then kind of going forward from there. You can also use it to prove chemistry and physics theories. Putting it, I know it was really hard for me in high school to kind of visualize things that they just kind of like drew on the board, right? So being able to be hands-on and seeing it come to life was really helpful. Doing, you know, homework in, it would have been really helpful doing homework in high school, right? And then obviously here during lab, it's really helpful to see it. Knowing that like I did it is also really, it's really a good time to know that the things that I'm learning has been applied. Other people also use it for interactive prototyping. If they're coming up with a new project and they don't want to, you know, buy the material quite yet to kind of make it permanent, they use the Arduino, right? I know Amy and I have been doing that. We kind of use the Arduino to prototype before we like saw together, before it's like a permanent connection. And then we know it's working, then we go also use it for musical instruments to do that as a fun little experiment. I don't know if your kids would be into that, but Amy and I thought it was cool. So this
Hey,
next,
Linda,
yes,
you cut out for a couple, like a minute or so.
okay, where did I stop?
I don't remember. Does anyone?
It was around interactive prototyping.
Okay, thanks, Joey. Yeah, so interactive prototyping, a lot of people like to use the Arduino to kind of test before they make any solid connections. Like Amy and I have been doing that in lab lately. We're trying to build a digital scale. And so we've been using the Arduino to kind of make sure that the input and the output is correct. We put like a known weight on the scale and we make sure that the Arduino is giving the correct weight back out before we make any solid connections, right? Because we don't want to like unsolder or like, you know, take back any connections and kind of mess up the wiring and mess up the wires because, you know, the wires are tiny and they, once you put it through a lot of stuff, they might not react as well. So that's also been really great. It's really efficient. We don't have to rebuy parts and things like that. And then a lot of people also use it for musical instrumentation. They plug it in and kind of write code that could, you know, play music, play a song before they, you know, maybe perform it or something like that, just to make sure that everything sounds right to the ear as they think it should sound. My first project is actually going to be showing you how to play the Star Wars theme song on the Arduino. So I don't know if your kids will be into that, but you know, Amy and I thought it was pretty cool. So. But yes, obviously a lot of things you can do. The capacitor, obviously you can charge it to hold charge, and then you can use it to charge other electrical components. The diode controls current. You can use that. Obviously the tilt sensor, I'll be showing that as well. And then I will also be showing the LED. You can do a lot of things with LEDs. I know last semester for senior design, we tried to build like a Wi-Fi transmitter with an LED. It was really difficult. Don't recommend it. Amy and I were in that class. It was, as a senior in college, we still couldn't figure that out. So obviously, there's a wide range of of projects that you can do. And I also have a lot of resources at the end of this presentation that I will give you guys that kind of ranges for those projects for your kids as well. Okay, so this first project is a Star Wars theme song, like I said. So super easy, right? Like in this kit, it comes with this like buzzer, and then it just comes with like 2 prongs. I don't know if you can see that. 2 prongs, and you just plug it into the circuit board. I have a little schematic here. So this green line is plugged into pin 5. You can use that pin, but if you use pin 5, it won't make any sound. It'll just flash this LED right here on the Arduino, right? So if you don't want that, if you want sound, you want to put this second pin in pin 8, and that will give you sound from the Arduino, as well as the LED blinking. And then of course you need to have the other pin in ground. Every circuit needs to be grounded just to make sure that, it's getting the correct power amount, the correct connection. So always just remember one side has to be grounded, and then the other half you can figure out, but half of it is grounded. That's like 50% of the work. So I didn't want to build the circuit and show you guys at like an awkward angle. So I took a video of all the stuff that I made. Hopefully let me know if you can hear it. Yeah, so that's the Star Wars theme song. It's on an infinite loop. I didn't think you guys needed to hear the Star Wars theme song for like longer than that. So it goes on an infinite loop. The code I can show you here in a little bit as well. It's just, it depends on that resonator that I talked about a little bit earlier, depending on the clock inside the Arduino. So you can code it to be however long the sound to be, however long you want for the clock to sound. And so depending on that frequency of the sound, it comes out as a certain song, right? So for this one, it's very dependent on the Star Wars theme song. You need to figure out the frequency of each note, right? But if you wanted to do a different song, you just change those numbers to the correct frequency, and the Arduino will just be like, okay, sure, let's do that, right? Super easy. You can see from, here, it's just 2 connections. And then it just plays the Star Wars theme song on an infinite loop. So I know as I was like trying to do this, I didn't know it was on an infinite loop. And so as I was trying to like build the circuit and like embed the video, it just kept playing. And so I had the Star Wars theme song like stuck in my head for the next like 3 hours. It was great. So this next project is, oh, no, see, infinite loop, I'm telling you. Okay, here we go. So this next one is a Morse code translator, a little bit more advanced, but still not super difficult. So you just need an LED, which comes in the kit, and then also a 220 ohm resistor, which also comes in the kit. The kit comes with a bunch of different types of resistors. It has obviously these that come with like, already made like value, and it also comes with a potentiometer, which is one that you can change and twist. That one is really helpful. We had to use those as well if you can't find a certain resistor value that comes already made. And then doing like resistor math is not fun, like trying to figure out if it needs to be like a parallel connection or a series connection. So potentiometer is really helpful. The kit that we will be giving you comes with a multimeter, which will help you measure the potentiometer value, which is really helpful. It's really difficult to kind of figure out, the potentiometer has like things on it, but it's very fickle. So always use the multimeter to measure before you use it. And then, like I said, you see here, this yellow one is to ground. It's grounding your LED. And then you also need to ground the Arduino, but you can tell that the ground from the LED and the ground to the Arduino is in the same port. So the breadboard has 2 ports here on the side, One is for voltage, which is this red wire here. And then one is for ground, which is this black wire here. And that is always true for any circuit board. So as long as you have it connected to the same line, as you see is the yellow and the black. So those are both grounded, right? So then you can see on the line below, the red wire is voltage. So just make sure, they're pretty close together. If your circuit isn't working, always check your ground source. And then of course I have the project linked as well. So you can like blow up the schematic. I know it's a little hard to see right now. But also always make sure your circuit is grounded correctly. That's been a big issue. I know a lot of the times I'm like, why isn't my circuit working? And it's because I didn't ground it correctly. So a super easy fix, right? Just make sure it's in the correct port. And then also make sure that your connections with your LED and your resistor are correct. You want to make sure that they're also in series. You can see that the right side of the LED is the positive side, which you don't want to ground, right? Because if you ground the positive side, nothing will happen. So you also want to make sure you check the polarity on your LED. And then the resistor doesn't matter. You can plug it in like either side, right? There's no polarity on a resistor. Just make sure it's connected either in series or parallel. And then you also want to make sure it's in the correct pin. This is also in pin 8 again. That will flash the LED. And then as you write the code, when you're done, you compile, you load it to the Arduino, you open that serial monitor, and you send in whatever message you want to convert it to Morse code. And so for this one, I did elevate KU, and then it'll flash in Morse code on the LED. Yeah, so you can see it's super easy, really quick. Like the upload is instant, and then I had to be like really quick about recording the video because the LED just started like flashing, and I was like, oh, okay, here we go. And then obviously it doesn't save the message that you sent to the Arduino, so you can keep sending whatever messages you want through that serial monitor, and it'll change the Morse code to be the correct message that you input to the Arduino, which is really cool. Morse code is really fascinating. I don't know how to code in Morse code, but doing this, coding it was really easy. You just tell it like A equals like however many dashes, however many dots, right? And it'll just like know. And I'll show that code here in a little bit. For this next one, it's a little bit more, advanced. As I said, the kit comes with a tilt sensor. And so I use that to kind of show that the Arduino can also sense when it's, being tilted or being like knocked off its axis. And so here's the tilt sensor. It's really tiny. I don't know if you can see that, but it's like this like rectangular box right here. It comes with 4 connections, but you only use 2 of them. It doesn't matter which 2, depending on how you put your sensor into the board. And then you need a 10K ohm resistor, which also comes in the workshop kit. Put this back in. And then, of course, you need to ground your circuit again, right? Ground one side of the sensor. And then you want to make sure your resistor is in the right port with your sensor. And then connect the other half of your sensor to pin 2, which is connected to this LED, which is lit up here. If you can see right here, it's a light like orange, yellowish orange right there. And then when you tilt it, you can see that the LED goes off. So it's telling you that the Arduino has been knocked off its axis, and that the sensor inside has actually like 2 or 3 little balls. And so you can, I don't know if you can hear, I don't know if you can hear it. Can you hear it? I don't know if you guys can hear that a little bit, right? Yeah. And so once it's tilted, that ball obviously, turn will move and kind of knock it around inside. And so that Arduino can sense that. And so when it's been, knocked off its axis, it'll tell you by turning the LED light off. And so I thought that was really cool. Obviously a really simple circuit, but you can obviously teach, physics theories from that, if you're doing force, if you're doing, things like that. I know it was really difficult for me to kind of understand those things. Even still now, engineering physics is half my degree, doing like Newton's laws is still really difficult for me. So if I was able to see this, as a high schooler or like a middle schooler when I was first learning physics, I think that would have been really helpful. And then obviously when you put it back to its correct position, the LED light turns back on. So I really liked that. And then this next project is really advanced. Okay, so earlier I said you could build your own Arduino board. On the Arduino site, it comes with everything that you need to build your own Arduino board. So I got this directly from the Arduino site. And so everything in the Arduino board, which I can show you here. So everything in this board, in this Arduino Uno, is broken down in this PDF, in this circuit schematic. So everything that you need to build your own Arduino board is shown here. So every part that you need is labeled. So some of these you can see are resistors, which you can get, right? And then other things are a little bit more advanced, like up here, these inverted triangles are op amps. So you would need to get op amps, you would need to get resistors, you see some capacitors, you see some diodes as well that control the current that flows through the Arduino. So everything that you need to build an Arduino board, if you so choose, you can do it. If your kids are, like to really work with their hands, or they're just really interested in like what made the Arduino happen, you can do it. I don't know if I would personally suggest it. There's a lot of moving parts, there's a lot of moving connections. And so it can get really tricky, and it can get kind of hard to troubleshoot if you're missing a connection or a connection is incorrect. You can see here that there's a lot of ports that need to be connected correctly. And sometimes the ports aren't, easy to read. And so it can be a little difficult, but hey, if your kids are willing, then like I'll go for it. And then, as I mentioned, so additional resources, the Arduino comes with built-in libraries that come with examples as well. So those libraries can control like servo motors. We actually use servo motors to do like simulate a self-driving car in one of our classes. So that was really cool. The Arduino comes with a library that controls servo motors. And so all you have to do is you just download the zip file of the library, and then you upload it to the Arduino IDE that I'll be showing here in a little bit. And then how to install that like step-by-step, I've linked here straight from the Arduino website. And then there's also a library of projects that have been completed with the Arduino that have been done by like everyday people who just think that the Arduino is like really cool. And I've linked that here. There's like pages of projects, pages. And they also range from, easy to long to difficult. There are some that do like 3D printing. There are some that do, like automated motions with the Arduino. It's really cool stuff. I like spent way too long just like going through that website. And then the build your own Arduino board is under the documentation from this website. It comes with that schematic that I showed you. It comes with the zip file. It comes with the circuit diagram. You can use that circuit diagram and simulate it before you, like do any permanent connections like I talked about, to see if it simulates correctly. And then the project links are here. All the ones that I did, the Star Wars, the Morse code, and the tilt sensor. All the code is there, the schematic is there, and then the description of the project is also there as well. Yeah, are there any questions? Does anyone want to see the IDE in more detail, or I can pass it over to Amy to do the makey. I don't know how long I've been talking. Sorry if it's been a long time. I hope this was helpful. I know I like kind of went like super fast. But again, I didn't want to show you like all the circuitry at an awkward angle. So
I don't know if I'm like allowed to ask.
Go ahead.
I kind of want to see the code.
Ask away.
I just want to see the code because I remember.
Oh yeah.
It was super cool.
Let me open up the Arduino app. Oh, I'll just share this whole thing. Okay, okay. Can you see my search bar, the pop-up?
Yes.
Okay, so here's the Arduino IDE app. So I just downloaded it from their website. Again, super easy, the usual like allow permissions and things like that. And then you open up as an app, maybe. I got a lot of tabs open, so it might take a minute. There we go. Okay, so as you can see, do that later. For the Morse code, you input char, which is characters for your Morse code. And so for A, it's this right here. It's a dot dash, right? And then you separate your code with a comma, because this is in C++. And then so for B, it's a dash dot dot dot. And so your Arduino can read that and it'll know, right? So this first line is A through I, and the second line is J through R, and this last line is S through Z. And so, you just like bring up like a Morse code, like, table, and then you just like hard code it in there. But we're gonna give all of you guys this, so you can just like copy and paste it, it's fine. And then obviously like for numbers, if you input numbers in your messages, it's obviously different in Morse code, so you code that as well here. And then you can also change this delay here for how often that LED will flash, right? So if you want it to be a little bit quicker, you just make it like 100 or something. If you want it to be slower, you can do 300, 400. That's really up to you. And then here obviously is like your pin for which pins you plugged into the LED or into the Arduino, excuse me. And then the begin just kind of tells you how long it waits before the LED starts flashing. So you can also change that as well. And then obviously it's on a loop, right? So you want it to keep flashing. And then you can change it as often as you want. And then down here is just, some logic, as Antoinette talked about, the else if statements, it's just checking to make sure, what's been entered, what's which loop and which like line of code it needs to call to give the correct Morse code. And then let's see, what else do I have? And then here's the tilt one right here. So here it talks about your input pin, which is 2 on the Arduino, and then your output pin, which is 13 on the Arduino. You can change those too. You don't have to, it's not like hard coded into those pins. Just make sure if you change it, if you change 2 to 3, you make sure your circuit connection is to pin 3 on the Arduino. If it's not, it won't work. And then you'll be like, why isn't my stuff working? And then, yeah, it just talks about like how to read in your LED, if it's high or if it's low. It stores that information below here in this logic, just to kind of know like when to flash, or the LED on the Arduino, when to flash, when to not flash. It's reading that information from that tilt sensor. Yeah.
Very cool. Thank you.
Yeah, no problem. Yeah, since we're here, I'll talk a little bit about IDE as well. Like I mentioned here, this is the verify, just to make sure your code is compiled correctly. There's no errors. Here's the upload button to send your code to the Arduino. And then the serial monitor here. Okay, I don't have my board connected currently, but a new window will pop up, and then there will be a line to where you can send information. It's just like a text box, and you type whatever you want in there and you press enter and it'll send it to the Arduino. And then right under that, it'll just kind of run and show you everything that comes out of it. Yeah, and then we'll be sharing all of this information with you all. And then of course, you'll be getting the Arduino. So if you guys come up with any like really cool projects, you should tell us, because I was like really amazed with like this stuff. And again, 4 years of engineering, and then I was like blown away by playing Star Wars on an Arduino. So oh, are there any? Okay, I can't see the chat when I'm sharing. Sorry, let me unshare and I can answer, see if there's any questions. Okay. So the Arduino is also quite inexpensive, just because it's also open source and you can build it your own. I think our Arduino, like this Arduino Uno, which is the most popular board, I think is like $25 on their website, but we'll be sending you a kit that comes with the Arduino, with the USB cable, and then everything that we talked about here today as well. Yeah, it's really useful. I know like we're using the Arduino to do like Bluetooth as well in our senior design class. Yeah, you can do a lot of stuff with this.
Right now we're using microbits in one of our classes. Do you know how it compares to that?
We've never personally used microbits. I don't know if Joey, Amy, if you guys can, no? Okay, yeah, we've never used microbits. I think I would personally assume that the Arduino is a little bit more flexible. You don't have to, you can just kind of override your code. You can kind of do that. It's really flexible. It's really versatile. You can, yeah, but I can't speak a lot on it. We've never used microbits. Are there any questions? I hope this helped. I had a lot of fun. I hope you guys will have a lot of fun.
That's a great presentation. Thank you.
Thank you. Thanks for coming. All right, Amy, you ready? There we go.
All right, so I will go ahead and start sharing my screen, and then we'll move into the Makey Makey lesson. If you all want to go ahead and just pull up like Scratch, and then I'm going to start this poll also while I'm pulling it up. So if you, it'll take me just a second if you want to answer this poll while I'm doing that. That would be awesome. Can you all see the poll? Okay, perfect. All right. All right, and then is there a second question for you all on the poll? No? Okay. So I'm going to end this one, and then I think I can go to the second question. Okay, here's the second question, if you all want to answer that. Okay, awesome. All right. So I just wanted to ask those questions to kind of get a better understanding of kind of where everyone's at in terms of Makey Makey and then in Scratch. I know Scratch is a pretty popular resource for coding, especially block coding. So just to kind of get started at the very beginning, I'm going to go very basic, so it might not be applicable to everyone, and then I'll go into some more advanced lessons. But before I get started, once again, my name is Amy Lusler, and I'm a senior in computer engineering. And I, throughout college, have been really interested in volunteering and helping students learn how to code. So myself and a few other individuals, we started a coding organization to teach middle school students how to code. So we did that for a while, and we went to different schools. However, we were kind of having some issues getting volunteers, with college students having pretty crazy schedules and having classes and exams and labs at different times. So we were finding that we weren't able to reach as many schools as we would have liked to have. So we decided to kind of, with this capstone, change our direction. And since we're college students and not teachers, and we don't know kind of how to teach students, and we have the technical side of things that we learn in our classes, we really thought it would be a good way to reach the students to have a collaborative session with the teachers and kind of have a better understanding of what's in the classroom, what's currently being taught in the classroom. Obviously, we don't know anything about standards or anything. So feel free to chime in at any point during this lesson. I really want you all to tell me like what the students know and what they don't, so I have a better understanding. So yeah, so we'll go ahead and get started. So the purpose of a Makey Makey is a kit that uses everyday objects to create possibilities that foster innovation and creativity. So at first glance, the Makey Makey really doesn't look like much compared to the Arduino, especially. It just has these like little holes. And to be honest, before planning this conference, I had never used a Makey Makey. But you can also have more possibilities by using the back of the Makey Makey. So it really can go from very basic starting out and then go further with the possibilities on the back. So, and by saying everyday objects, basically what the Makey Makey does is it allows you to create a closed feedback loop. So basically it's taking like your space bar or your up arrow and your down arrow and replacing those keys with something else. So that could be a banana, or that could be a can, just other conductive materials, so that when you touch them, it's like you're touching your space bar or touching your up arrow. So what is in the box? So when you first get it, it's in a box like this, and it has just another box inside of it. This is the one that we'll be sending out. And then on the inside, I've already unboxed it, but so there's the Makey that comes in this red bag, which is what I just showed you before, this board. And then it also comes with a fun sticker for your laptop. So, and then you also get, and I will move on to the picture. You also get directions that are for just starting out. So that come in just kind of like this, and they just tell you how to connect it to your computer, but we'll go over that here in a second. And then it also comes with these little connector wires that can be used to expand the possibilities of the board. And then it also comes with a USB cable, which is what you're going to use to connect the board to your computer. And it's a standard USB on one end. So there's no need for another connector unless you have certain laptops that don't have USB ports. And then you will get in the kit also 7 alligator clips that are just different colors that are used to connect different objects to the board. All right, so to connect it to your computer, I just wanted to go ahead and do that. So I know you all don't have a Makey in front of you, but once again, we'll be sending out these slides. So if you forget, that will be in the slides, or if students are going through it, they can use this as well. So using the micro USB side, it just plugs in up in the corner, and then it plugs directly into your computer. So, and if any notifications come up that to connect a keyboard, you can just exit out of all of those. So then to test if it is connected successfully, you can go to any Word editor, Microsoft Word, and when you touch the space key or the click key, that should actually represent what you're doing. And then there's also a light to show that it should be working. So if you go into a Word editor, that'll be all your different keys. And then you just need, to get started, you also need to ground the Makey board. And, oops, sorry, I just used the click button on the Makey. So what you're gonna do is connect it to the bottom of the Makey, as you can see in this picture. So this is where the ground is connected. And as Linda was mentioning before, the ground is the negative side of your connection to make sure that you don't overheat anything or start a fire. So it's a way of regulating that. So if you're going to test these, you can connect to ground and then you can click. So as you can see, I'm controlling the PowerPoint right now with the Makey. So that's as much as you need just to get started. That's all you have to do. All right, so just a little bit about why the Makey works the way it does. So it's based off of conductivity, and the alligator clips are acting as the wires and conducting through the Makey to whatever object you're using. So for conductors is a material or device that conducts or transmit heat, electricity, or sound. So these pictures show just some of the different types of conducting materials. So we have aluminum foil, gold, a metal spoon, pennies, graphite, water. So each of these things could be used, oh, and gummy bears. Each of these things could be used to control the Makey. So something that would be really cool is if you asked your students to name other conductors, or if you didn't show them any of these pictures and you asked them to name some different types of conductors and then show them. I know that when I started college, I actually started in chemical engineering. So I didn't know a lot of these like really basic concepts. I mean, obviously I knew some things conducted heat and electricity, but I think the Makey really furthers that by understanding the difference between conductors and insulators and testing different things. It's a really hands-on, guess and check kind of thing. And then also combining that with the software side of things, which we'll do here in a second. Oh, the Makey works better than my actual mouse. So in terms of insulators, is a material that does not allow electricity to pass through it. So here in a second, I'll show some examples of projects that I've created. But some of the three main ones are wood, rubber, and obviously paper because of wood. But also, once again, just asking students to think of any insulators or conductors like around your house is really a good way to start learning about electricity and furthering that concept, because a lot of computer engineering is learning about circuits and learning how to connect circuits and learning about batteries and how they connect to your circuit and how you're supplying your circuit with power, which has a lot to do with conductors and insulators. And once again, another thing you could do is just having animations on these pictures and having it more of a students guessing. Okay, so I understand that a lot of you don't have Makey in front of you, and a lot of you also haven't used Makey. So if you want to copy, I will copy this link into the chats. And if you want to go ahead and go to this link, it actually is a Makey that is virtual to kind of play around with. So I have posted the link in the chat. So if you want to go ahead and go there, I will also do that.
Also totally off topic, Amy, but it makes me feel better that you also have a bunch of tabs open. This is the norm
Actually,
for, you know, college. It's just like a bunch of tabs open. So
yeah, and I even closed them out before I started.
Honestly, me too.
All right, so this is the virtual Makey, and you can even add on to this as a project for your students.
We didn't get the link in the chat.
Oh, you didn't? Oh, sorry, I didn't send it to everyone. All right, can you see it now? Okay, perfect. All right, so this is, as you can see, the Makey as I showed you before, and they have a couple items already here that are ready to just be used. So you actually don't have to program anything. So you have the ground wire, which is what I just showed you before, kind of like in person. And then you also have this wire that's connected to this space. So if you place the key, sorry, I already have the banana there. If you place the key there, sorry, it says conductive. So if you're placing, so you have the negative side and the positive side, the two wires. So you can try out all these different things to see if they are conductive. So the banana is conductive. And then you can also try the leaf, and that's also conductive. And it plays a piano sound as well. So this is a good resource for students to kind of start out with if they don't have a Makey in front of them. Because I understand that you know, you may not have like a class set of Makeys, but this is a good way to prototype projects before they actually start, because you can increase the capabilities by adding different sprites or backgrounds, which we'll get to in a minute more on Scratch and connecting to your Makey. But to do this, to kind of simulate what is going on here, you can simulate it by using if statements. And by using like the green when clicked. All right, so we'll go back to the presentation. So that was just kind of the beginning, but to kind of tie it into the software side of things as well, being computer engineering, I think that's really important. So I know a lot of you said you had done Scratch block coding before, which is awesome. especially for elementary and middle school students. It gives a really good idea of how to translate concepts from scratch. It's the logic behind it, and actually put that into your code, whether that's Python or C++. The concepts are the exact same. So it's just a matter of taking it from the interactive interface and putting that into the code, just learning the syntax. So they don't have to learn the logic, they just have to learn the syntax. So, but some of the benefits of using Scratch, if you haven't used it before, it's drag and drop. It's browser based. You don't have to download anything. So I'm using my Makey that's connected to my computer, and I can use it with Scratch online. And there are a ton of pre-built projects for examples. And like I said before, you can go from super basic to really complicated, which allows students to explore and really learn the concepts of coding and hardware. You also, and Antoinette showed a lot of this earlier too, is that you get shapes for guidance of what to connect where. So I have used Scratch a little bit, and I've also used regular coding, Python, C++, and it does take a little bit of getting used to, but once you know the coding or the Scratch side of things, it makes it really easy to build projects quickly if you have something in your head. Just to kind of start off, I know there was a question earlier about how to teach students Python or strings, those concepts, after they already know Scratch. And I think a lot of it translates really well, starting with the Scratch. I know it's a lot more basic than having to know the syntax, but it is a good start. So the first thing is if statements. So if statements are basically showing you cause and effect. So if this thing happens, then do this other thing. And if statements are used in all other programming languages. And like I said before, it's just the syntax that varies between the languages. So you can add on to this if statement by having an else statement, which is like an alternative. So if you said, if it rains today, then I'll wear a rain jacket, else I won't wear a rain jacket. So your statement inside of that like hexagon or whatever it is would be if it rains today. So it rains today would be inside of that statement. And then inside of that white statement that kind of has a groove cut out would be, I will wear a rain jacket. So these are really helpful in coding to provide different paths and options. So what you could have your students do is build a simple if statement program. And that if statement program could just be, if my mouse is touching the cat or the sprite, then I want it to say hello. And obviously this is like, you could create so many different versions of this program or to show if statements. But this is just a key of one that you could use. You could take out this slide and have them build it and then check it after that. So you have when the flag is clicked, it's going to start checking to see if it's touching the mouse pointer. The wait 2 seconds is there because to move your mouse from the green flag to the sprite, otherwise it will execute automatically pretty much. So the wait allows you to move your mouse to the sprite and then it will recognize that it's touching it and then say hello. So, oh, and here's another program that's a little bit more difficult and requires some other different type of blocks. And I'll show you how the other ones you could also use for more advanced if statements programs. So you can have when the green flag is clicked, it will go to a random position. So you'll see here that when the candles touch the tree, it says fire. So that's all it's doing. It's just moving to a random position and then it says that. So the next concept that is also really important in programming are for loops. And Antoinette also touched on this before also, but for loops allow you to repeat steps a certain number of times. So the repeat until is probably more like an actual for loop because you can set the ending conditions in the beginning conditions. However, there's also this one that already puts it in a certain number of times, repeat 10 times. So this is also really helpful. So you're not hard coding everything that you want it to do 10 times. You only have to do it one time. So if I wanted to say hello 10 times, I wouldn't want to type it 10 times. I would just want it to say it 10 times. So an example program for the students to do to kind of show their understanding of for loops is I created a program that just makes the ball move to 10 different locations. So it's pretty simple program. And once again, there's so many alternatives you could do with this. This is just a starting idea. All right. So the next type of loop that is really helpful when you're coding is a while loop. And while loops and for loops can do pretty much the same things. However, while loops repeat infinitely. So the way they show this in Scratch is by using a forever block. Normally a while loop actually is while and then your parentheses or whatever program you're using. And you could put a statement into your while loop in normal programs like Python or C++. You could say like while true, then you would execute it infinitely and then it would break if it's not true. However, this is a simplified version that just says forever, and then whatever you put in there will continue until you hit stop on your program. So an example of this, I just had it print my name repeatedly. So you can add costumes and just have it say your name over and over and over. This allows the students to actually insert costumes so they can learn about that for their Scratch program and then change between all the different letters. And just in case, and I'll show costumes and backgrounds here in a second, how you can actually upload your own, which is really helpful for inventing new things and coming up with new ideas instead of using their default backgrounds. So the next thing that's a little bit more advanced is logic statements. So there's an and statement, an or statement, and a not statement in Scratch. And these are, once again, used in Python, and all the other languages as well. So the first one, and, it's saying if two statements are both true, it will execute the program. So this is really helpful to say, to check if to verify two different things. So if I wanted to say, if it's cloudy, or if it's cold and it's snowy, then we'll have a snow day. So both of those things would have to be true for us to have a snow day. And for the or statement, it would be something like, if I finish my homework or I do my laundry, then I'm gonna take a break. So one or the other. So only one of those has to be true for you to execute that statement that follows under it. And then the last one is a not statement. So sometimes it's not always helpful to just have an if true statement. So sometimes you want to have a not statement. So if you wanted to say something like, if it's not raining, then I'm going to not wear a rain jacket. Or if it's not raining, then I'm going to wear sandals. So it can simplify your programming by using the opposite or the negative of what you wanted to say with possibly not having a not statement. But the symbols that I included next to the and, or, and the not, those are the actual syntax for using those like in your Python code or your C++ code. So you would use and, or the exclamation point for not. So this is an example program, kind of as I mentioned before about the snow and cold. So this would be to use the and statement, you have to use a couple different blocks and items. So something that's a little bit different for this one from the other ones is you have to actually create variables for this specific program. Obviously, you can show this in a lot of other ways, but variables are really important, and variables are a way to symbolize values, just like in algebra. So I created a cold variable and a snow variable. You could make those random. You could to actually check those statements, because there's not really a ton I need to check the statements right now since we set them both to true, but those could be randomly generated, and then you verify if they're both true or not. And then it will say snow day if both it is cold and snowy. Okay, so then here are the first one is a really cool program that I wanted to make sure point out specifically. And the other one is the resources for just all makey. But before we end the lesson of today, I actually wanted to build some programs. So if we go back to Scratch, you all are probably already there because of the virtual makey. But I created a couple different programs that I wanted to show you all. And these can be used with the makey or without the makey. And I'll kind of show how that works. So right now, this program is meant to allow you to either subtract or add the numbers. So I'm going to go ahead and connect it to the makey so that I can use my little like touchpad to add or subtract the numbers. So to do this, to create these buttons, I'm going to do subtraction because that's one I just have right here. So I just created a paper circle and added some aluminum foil on the bottom because, as I said before, paper is an insulator. So I'm going to go ahead and take one of the alligator clips and connect it to the aluminum foil. And then I'm going to connect the other end of it to the space location on the makey. Okay, so once that's connected, when I want to actually touch, and you would have to touch the aluminum foil to get it to work. So then to start this program, to get the subtraction button working, I coded when the space key is pressed. So whatever correlates to the space key, that's what you would use in your Scratch program, or that's what you would connect your button to. So it's kind of hard to see this, me touching the actual buttons, but right now I'm currently touching the ground wire, and then I will also touch the aluminum foil when I want to have the numbers added or subtracted. I don't have an addition button currently, but I can just also hit the up arrow instead for that one. So if I hit play, it's going to show me two random numbers. And then I just hit the aluminum foil, so it subtracts the numbers for me when I hit that. So if you had students that wanted to go ahead and try it themselves, like the subtracting, they could do that. So then I hit it again, and it shows me that it's subtracted. If you don't want it to show negative numbers, you can allow it to, you can use the conditions to set it to not do negative numbers. You can do that with the coding if you want to make it more advanced. But this would allow students to just kind of go through and subtract the numbers. So the way I created this program, just in case you're not familiar with Scratch, I'll just do this really quickly. So to create so normally with variables, it's very hard to see them because they're really small. So you could just do this by creating variables and have it show those values. So if I have A, it'll show, I can have it show A on the screen. But as you can see, this number is pretty small compared to the other one, and it's not very fun looking. So you can add your own numbers in. Scratch actually has a lot of numbers already built in. So we'll go ahead and take that out. But to get to these numbers to display, I went to this sprite down here, and then I went to costumes. And then in the costumes, I added 1 through 9. So I have one object and it goes 1 through 9. So when I go back to code it, I'm having it pick a random costume from 1 to 10. So the reason why it knows what the value of that object is because the costume number is the same as the number, if that makes sense. If you go into costumes, 1 is 1 here. This value, this number 1 is costume number 1. And this number 2 is number 2. So if you wanted to add 0 in, then you would have to change your code to accommodate for that. But to make it easier, especially if it's just addition and subtraction for like younger grades, you don't need to do that. And it makes the code simpler that way. And then, so I'll show you the code for the other number is the exact same, and you can just copy and paste it. And like I said before, variables are really important, and that's how I was able to do the math operations here, is by creating 3 variables, A, B, and answer. So it's taking those costume numbers and it's adding or subtracting them. And then it's storing that value in answer. So the sprite, that's the bat, just has to say the variable answer. And there's no extra work needed. So this is a program just for like addition and subtraction. And you can add on to them actually by using more alligator clips and more buttons. You could do multiplication, division, subtraction, and addition by just using the different functions on Scratch. The different math operations that are located in the green section. Does anyone have any questions about this particular program? Okay, so I will go ahead and show the other program that I created. So this one, once again, is more of a younger level one, but I'll show one at the end that requires a little bit more coding. So this one, actually, what it does is if you have a button that is, I'll show you my other button that I created. This button is just a blue button to show the color. So you can connect that one instead, and you could connect a whole bunch of different colors, whatever you want. And then what happens is if I touch this button, it will say blue. And this is connected to the space bar right now, my current program. So right now, I actually need to change it to the up arrow because that's just how I coded it, but it could be anyway. So I'll show you once again how I have it connected. And it's an awkward angle, like Linda was saying. So it's connected to the up arrow because that's how I have it in my code, and then also ground. But if you wanted to connect more, you would obviously just need to add more alligator clips and more buttons with different colors or whatever. So then what you can do is with this one, with this program, if I'm touching ground and I hit play and I hit the blue button, it plays the sound blue. And so then if I touch the blue button and the down arrow, which would be another shape that was, connected as a button, if I touch them both at the same time, which might be kind of complicated since I don't have buttons in front of me. So it actually shows me what happens if you mix the colors. So if I'm touching both blue and yellow at the same time, it tells me the output. And the code is a little quick when you keep touching it because it's still conducting electricity. So it just keeps going and going and it acts like it's still being touched. But what you can do is, even if you're not touching both at the same time, if I'm just touching ground and the blue, it will continue to show me new random blue objects and play my blue recording. But what you can do is continue to add other blue objects just to get students familiar with the color. And it's, once again, a very basic program that they may not code, but you could also code it for your own use and to introduce kind of Scratch and its possibilities. So the last program that I did that is a little bit more advanced on the coding side, the Makey Makey is pretty basic here, but it is a vending machine program. So I uploaded my own background, and then you can make these anything you want. You could use chip bags or you could use other different snack items. But I ended up creating 4 variables for the different items. So for the soda cans, for the water, and the tea. And I specifically chose these because I know that cans are aluminum and they're conductive, and that water is conductive and tea is conductive also. So I chose those because I know that when I touch those things, it's gonna allow me to not add anything else. I can just touch the can directly and it will recognize that I have pressed the space bar or I have initiated the Makey Makey. So in this program, I connected it to space. So I'm going to move my alligator clip to the space bar. or to the space on the Makey Makey section. And so I also have a can. It's not really that important that it's a can, but because it could be any conductive item. But here it's connected here. So then when I click the program, it's going to go ahead and set all the counters to 25. And then when I click the can, oh, sorry, I'm not touching ground. Okay, so now that I'm touching ground, it will play the dispensing noise once it's touched. So the reason why this may be a little bit more advanced is just because it requires variables and more coding. So this could be more of an inventor project if students are to just utilize the Makey Makey and coding. This would allow them to just upload their own background, their own sprites. This is much more just visually appeasing than the other ones. But as you can see, you can go from super basic to much more advanced with your program. So just to show you all the lesson that I thought was really cool, that I think you all should check out, is a money program that you can use with your Makey Makey. Similar concept to the cans and the vending machine idea, but what it is a money counting program. And it also requires a little bit of building, so a little more hands-on. You can connect different coins because they're conductive and count the money. So if you had a set amount of change, you could connect each coin to an alligator clip, or in this case, they connect aluminum foil. So then when the money slides down, it recognizes that one has been inserted. So then at the end, you could have it sum the total amount. But I thought this was a really cool lesson. I just didn't know if you all would be able to see like the cardboard and everything on the screen. But yeah, this would be really interesting if you had students like create a store, or if they just needed to count money or learn the concept of money. This involves the coding, the hardware, and also just the concept of money, which is really helpful. And also doing the math on the coding itself. It would require variables and many other things. So this is a really good lesson plan. Instructables is really helpful. They show you just how to cut things. But there's so many other things you can do, like playing the piano with your Makey Makey if it's more of a music-based lesson. But I think the most important thing to know with the Makey Makey is it's just really kind of showing how the hardware and the software connect on a really easy, and it's a really easy way to do so, because you just have to connect our alligator clips. You don't have to use a whole bunch of different materials. You can use what's around your house to show the difference between insulators and conductors. So it's really helpful just to represent the ideas, even if they're not really building hardware. It's a good start to that. So yeah. So it is 11:12 now, and we are going to have our guest speakers at 11:30. So we're going to go ahead and take like a 15 to 20 minute break just to kind of, if you have questions, we'll be kind of waiting here. And also just to kind of get a break from everything we just talked about for the past like hour and a half. And if you need any resources or just to play around with the Makey Makey. But Haroon and Allison will be joining us here soon. So if you could be back here by like 11:25, that would be awesome.
Amy, can I share a quick story with you? Because your ground made me forget.
Yeah.
When I'm sorry, my camera's not working today, but when we used the Makey Makeys, I bought a bunch of kid-size hair bands. And we called them power bands. And so I was like, put on your power band, and they put them on their wrist, and then they clip the alligator clip to the inside of the band, and it holds it tight against their wrist so that they can have both hands free to make connections. We do ultimate controllers. We code a drop game in Scratch, and then they make an ultimate controller. And then people go around the room like a fair and play each other's games. And
that's so cool. That's such a good idea.
But we have a whole collection of power bands. I'm that lady who goes to Dollar General on a regular basis and buys the smallest version of hair bands I can find.
Yeah, that's such a good idea, because you know, sometimes like if you have multiple different things and you don't want to hold ground, like when I was using it, I was just clipping the clip to like my pinky, but that's a much better idea. Instead of having, you know, little alligator marks.
You find a 14-year-old boy with a clip to his ear, you need options because they have high pain thresholds and think they're hilarious. So
yeah, definitely. That's a really good idea.
Yeah, but see, like I said, like ground.
Yeah, that ground is always a problem no matter what.
It still
Even
is
in
to this
our
day, you know,
yeah, what was our first project?
Still a problem.
Yeah. I'm not screen sharing anymore, right? Okay, no. Get started. So I would like to thank Haroon and Allison for being here today. Haroon is a regional manager at Microsoft Teals and has experience in the classroom. And Allison is an associate regional manager at Microsoft Teals. So I will go ahead and pass it off to Allison.
Great. Let me make sure, can you guys hear me okay? Excellent. I know Haroon has been here this morning. He's been really excited, been kind of passing back those things, you know, just about this conference, and it sounds like it's been a great experience. So sorry, it took me a moment to get my audio set up. So, you know, always the joy of technology. Let me kind of at least introduce ourselves. Hide that. There we go. All right. So Haroon, who you've met, he's the regional manager out of Chicago. I'm based out of Kansas City. My name's Allison. Again, Haroon's, we're thrilled to have him. He has a large collection of experience in the classroom. He's just like, you know, a wonderful asset to the Teals program. I've actually have a background teaching at the university level. So I have a PhD in physics and math, and I used to do that. And then I would do STEM experiences, bringing high school students on campus. Absolutely loved it. And then I found the Teals program, and I've been here for about 3.5 years. So I'd love to, so thanks for inviting us and having us here. I do want to explain kind of what the Teals program is, and feel free to put whatever questions you have in the chat, any of those things. Again, as a physicist, I do lots and lots of questions. So Teals is a Microsoft philanthropy. Our goal is to bring inclusive computer science into high schools. And the way that we work is very different. We bring volunteers into the classroom. They have a 1-year commitment. So they're in the classroom throughout the entire school year. And they're there to provide that support team teaching that computer science. Well, that classroom teacher is able to learn computer science throughout the year. So we feel like this is like an immersive PD, and we just love the model, or at least I personally love the model. I think Haroon does too, because he's working for us now. So.
Yep.
All right. My fun PowerPoint is not letting me click forward. Give me a second. Let's try the Alt tab. It's here somewhere. All right. Nice. Let's try this way. Nope, I'm not going to do it that way either. Hey, there it goes. Sort of. Let's try that one more time. All right. Hey, that's the wrong direction. All right, we're going to do this old school. How about that? Can you guys see my screen like this?
Yep.
All right, let's see if I'll minimize the side screens for you. Make it as big as possible. There you go. All right. So one of the things I'm really thrilled about is that we are working on expanding the Teals program. We actually have a collection of new regions that we are expanding into, including Chicago, which is how I I am very thankful that we got Haroon to join us. I'm gonna have to put the thumbnails back so I can go forward. Let's try that again. And pardon the dogs. Normally I have a headset, but the headset's not working either. So it's been a fun day. Regardless of
Allison.
which, yes.
Sorry. So if you click like on the bottom right of the screen, like the book icon, it should be a presentation without being an actual presentation, because I used that earlier today.
Hey, look at that. Awesome.
No, the other book, like 2 ahead of it.
Like 2 ahead of it.
To the right of it.
Okay. So
it looks like an open book right next to the presentation one. On the bottom right.
On the bottom right. Notes display settings?
No. Next one.
There we go. This book.
Yes.
Hey, thank you.
Yeah.
Learned something new about Deals. Appreciate that. I want to say your name's Antoinette. Is that correct? Awesome. Thank you. So we really have 3 kind of buckets of curriculum that we work with. We work with an intro course. This is a broad-based introduction. We work with a variety of curriculum providers. And then we also have 2 AP courses, Computer Science A, which is Java. It is based almost, as akin to your first semester course in college, but then we also do Computer Science Principles, which is actually an AP course, but it's designed to bring more women and minorities into college or into computer science. One of the things I really love about this AP Computer Science P course, Computer Science Principles, is that most colleges, so like KU in particular, for AP courses, you need a 4 or 5 to get college credit. For Computer Science Principles, you need a 3. So I love that it's just an easier bar to go into and get that college credit. So one of the things that is my favorite thing about the TEALS program is that all of our pictures, we use actual students and volunteers and teachers because we want the pictures that we show to reflect our program. And so you'll see the smiling bald guy there in that picture. That is Magnum. Magnum is actually based out of Kansas City. He is in his 4th year right now volunteering for the TEALS program. So his first 2 years, he was working with me for local schools. And then what happened is as we were looking at his 3rd year of volunteering for the TEALS program, we started talking a little bit about kind of where he wanted to go. And Magnum grew up in a small town and where computer science wasn't even a thought. And the other thing that you need to know about Magnum is Python is his jam. That is his favorite programming language. And so we've placed him with an intro programming class in Smithville High School. He's in his 2nd year now. So what they do is they'll communicate through Zoom or any other video conference platform. And the idea would be is that you could actually volunteer at a school anywhere. So you can go back to your hometown, any of those sort of great things. But I also really love this because this brings computer science to those schools where you really can't, where in general you don't have a local volunteer who can go down the street. And then the other thing that I always like to point out with our remote option is that we actually started this about 6 years ago. And so we have an extensive list of best practices. And so just thinking about that in terms of, kind of how to make that remote model work, I think everybody a year
Do we? Uh-oh, what just happened?
I think I'm back in. Am I back in?
Yep.
All right, awesome. That was a little weird. So we all know a year ago when COVID hit, switching from in-class instruction to remote instruction could be a little bumpy depending on kind of who you were. Let's see, I bet I'm not sharing my screen again, am I? So let's do that. Same screen though. And so our best practices really made a difference, I think, in kind of making those experiences much better. So, and it really does, I think it really does help. So a couple of nuts and bolts that I always like to tell all of our schools is that we really do believe in diversity and inclusion, and it's not just something we say, it's something that we ask everybody to commit to. So we ask our schools to commit through in diversity enrollment. In other words, we want the demographics of that computer science class to match the demographics of the school, however that might be. So depending on what your population is we really want to look for that parity. The other thing that we really try hard is that when we have our volunteer teams, we work with them to create an inclusive instruction and inclusive learning space. And we, again, ask our volunteer teams to make those commitments. So in other words, we're not placing volunteers at your school unless they're making that commitment in terms of inclusivity. And so that's one of the things that I think is really important and one of the cruxes of our TEALS program. And then our volunteers are incredible and important, and you don't want me starting on stories about our volunteers because I will have plenty of them. But they are, from about 650 different companies all across the United States and British Columbia. And most of our volunteers have multi-year commitments, just like Magnum does. They are incredible, but they spend time over the summer on pedagogy, on like how to teach computer science and that inclusive learning, inclusive instruction and all of our and culturally responsive teaching, so that they are ready to go in the fall and actually, truly be part. And thank you for passing on the next slide for me. Couple other things that you can think about is just a few kind of nuts and bolts in the partnership. We ask that our classes are scheduled first period, and we only do work on the high school level at the moment. And the reason why is because it increases the probability that our volunteers can attend a class. The other thing that we also ask that you do is you help find volunteers, because those volunteers connected to your community are going to be the strongest, most committed volunteers. And then we always ask that whatever classroom teacher you have that's interested in learning that computer science, they have at least 2 years of classroom experience so that they can be in charge of all of that classroom management. So what questions do you have?
I think Serena had a question in the chat about the middle school, and if you have about middle school teachers and students, and if you have any plans to move to middle school.
Great, thank you. I'm afraid I missed part of the chat when my Zoom left. So at the moment, we're not servicing middle school teachers. And one of the reasons why is because really a summer PD for a middle school curriculum, you can usually do that summer PD and you're able to really teach it. But once you get into high school, the rigor increases. And so we want to be there to support those teachers, although it's a common question. Some of the curricula that we actually work with actually is designed also for middle school for students, especially especially in our intro curriculum. So there is that little bit of overlap, and there is a definite gray area, but at the moment we're just focused on high schools.
I have a quick question. Do you have resources on your website for some of like elementary school or middle school teachers to maybe access computer science resources or to develop their own program?
So our website is actually fairly focused on high school, but I will say that there's a couple great resources that I always draw people to. First of all, if you want to start, if you've done, and I don't know what you guys have done today, so if you guys have done this, please just tell me. Hour of Code, so hourofcode.org, it's code.org. The idea is Computer Science Education Week, which is about the second week in December. Every kid should be doing at least 1 hour of a coding activity, and there's unplugged and replugged activities. But one of the things I like it is most curriculum providers have done an hour of code, and they're all free. And so it gives you an opportunity to try a variety of different curricula and really, play it out, try it with your students, see what you think. And then if it's something that you want to kind of, pursue, then you have that curriculum. The other thing that I will say is that I know that Microsoft has their Make Code. We are a Microsoft philanthropy, and we really are curriculum agnostic, but I do know I have those curriculum resources available if you ever want that. Let me put my email in the chat as I typed in the wrong email. So there is that definite resource. The other thing that I would think that, really code.org has one of the best K-12 curricula that it's free and easy. And, you know, as a middle school teacher, I don't know about you, but I'm always for the free and easy curricula. So code.org is kind of like, you know, the place that I'd probably start off looking at. And then Make Code also, I know that they've just started building out those resources also. And so those, but I haven't done that in the middle school area. So I've just seen it because it's kind of part of what we've done. But really, I would do the hour of code. That is kind of my first and foremost, because it really does allow you to try it with students and realize, oh, this isn't going to work at all. So. What other questions can I offer? And let me add in Haroon's email also.
Yeah, I can put it in if you want.
So we're both available, and I'll stick in our website too. There you go. You're always welcome to look at our website. We have some resources. We also, you know, the other thing that when you're thinking about kind of computer science, the other thing that we have is we have some resources on kind of inclusive computer science education and kind of pulling that out. So if you ever want to contact us about that, we have a collection of guides on, like, you know, how do you involve counselors in your efforts, or, you know, how do you host an hour of code, some of those things. So if you're interested in any of those resources, please hook us up, because we're always happy to share that. We, you know, our goal is inclusive computer science. And so even though we're focused on high schools, we really do want to make sure that every kid does have the opportunity to reach computer science. So.
I have a quick question.
Oh, sorry, go ahead.
You can go ahead. Okay.
Oh, go ahead, answer that.
Thank you. So are all of your teachers, do they have a computer science background?
Not at all. So, you know, I have teachers who have a special education background, who have a religion background, who have a math background, social studies background. So we really don't care what your background is, because we have that intensive program. What we care about is that you're passionate about, you know, moving that needle with computer science. And so if you're passionate, then we're interested in working with you.
And so what goes into like the training of getting them to be able to like relay the knowledge?
Excellent. So we really have, and for some reason, I think it just didn't show up in my fun clicking through. We have 2 support models. So the first model is co-teach, and this is where we have a team of about 4 volunteers that each commit to be in the classroom 2 to 3 days a week, or 2 to 3 hours, depending on if your block schedule. And the idea is the volunteers will do the majority of the instruction. And so in this stage, this is going to be a new teacher to a new curriculum, you know, brand new to computer science. Their first job is just to kind of listen and absorb, and then eventually take on more and more of the instruction until they're ready for our lab support model. I will say it usually takes about 2 years to go into that lab support model. So it's not a quick process, but we also feel that by the time you're ready for that lab support model, you're taking on the majority of the instruction. And again, you know, usually it's about 80% is where you start off with. But you still have a team of about 2 volunteers in the classroom, because you want those experts available. And so again, usually most people take about 2 years in our lab support model also. You'll still be kind of expanding your computer science knowledge, and those 1 to 2 volunteers will be still in the classroom 2 to 3 days a week. And so you really do have coverage. One of the things that we feel is incredibly important in all computer science instruction is that the majority of time students are spending coding. And so you want to have extra pairs of hands as students are unblocked and kind of helping out with that process.
Yeah. Awesome. Thank you.
Anytime. And Haroon, you're welcome to answer these questions also.
Okay, no problem.
Doesn't have to be just me.
I had a question. You kind of talked about the teaching side. I was wondering about the volunteers, kind of the training they go through. What are the best volunteers?
Yeah. So, I've been here for 3.5 years. We have a wide variety of volunteers. Our volunteers, the best volunteers, are committed. They need to have a computer science background. So, I mean, they're the experts in the classroom. So, even if you're passionate, but we got a connection. We got a contact the other day from someone who has a background in HR, and they're like, "We want to volunteer." It's like, that's lovely. However, we can't accept you because we really do need you to know computer science. So that's the number one thing. The other thing is that I always like to be really upfront about the time commitment. We talked about that training over the summer. It's usually about 40 hours for new volunteers, and that includes spending time with your team, just trying to figure out who's going to attend what days. It's also spending time, learning about how to teach computer science, and that, and also how do you create a lesson, all of that sort of stuff, and also some time on your curriculum. So whatever you're teaching, we want you to look at it and be familiar with it, do a few projects before your students do that. So about 40 hours over the summer. Most of this is on demand whenever it works for you. There's a couple meetings, of course, that need to be with your team, and that'll be scheduled with your entire team. And also your regional manager, whoever's kind of in charge of that, your school. In addition to that, during the school year, most of our volunteers will do about 5 hours of a week of volunteering. So that's 2 to 3 hours in the classroom. And then some of that might be, lesson prep or planning, but also working with your team. So all of our teams pretty much have like a weekly meeting in some sort of way, shape, or form, whether or not it's like asynchronous or something like Teams, or synchronous where it's like every Sunday night or, right directly after class, where they can actually kind of talk through all of the different parts of, what's going on and what's upcoming and who needs to grade what and all of that sort of stuff. So that kind of gives you an idea of the time commitment.
So just to clarify, for volunteers, you're looking for high school students, and do you go above that at all or below that, or just high school?
So our volunteers, we would need volunteers who have at least 2 years of college. And other than that, that's fine. The other thing would be akin to industry experience. So we have some volunteers who, went to a boot camp or were self-taught and have been in the industry for a number of years. Those are people that are, are wonderful and welcome, but we do need that computer science experience and then just a couple years out of high school, just so that there's that little bit of a break, but not, not much. So about 2 years out of college, so if you're a sophomore now going into your junior year, we'd love to talk to you. If you're below that kind of grade wise, wait a year or so.
And judging by today's presentations about all of y'all, I think you all be great volunteers in the classroom. All of you seem like professional teachers right now.
That's awesome.
Mm-hmm. Oh.
What did I forget?
Oh, sorry.
Go ahead.
Did I forget anything? In what we covered?
No, I don't think you forgot anything. No.
I was going to ask you, Haroon, just in your classroom experience, what were some of the successful lessons you had, or what do you think were what could be some pieces of advice you could offer?
Yeah. Well, when I taught, Chicago Public Schools had just launched 6 different STEM high schools, along with IT industry partners that partner with each school. So we had Motorola, IBM, and Cisco. So one of the things was trying to make computer science, trying to make the kids more aware of computer science. So I would bring in like articles from the New York Times and Tech Republic, things like that, where, for instance, the guy who made all the kids were addicted to, I think it was called Flappy Birds or Floppy Birds or whatever. And I was telling the kids, I said, imagine if he charged 50 cents for his game, like do the math. And they were like, oh my God, and I would also bring in outside lessons about photoshopping. I would tell them, hey, when they talk about people photoshopping pictures to make themselves look different in magazines and things like that, I said, this is what you guys are doing right now. And they were like, what? Oh my God. And some of the things I would do was when I started teaching about IP addressing, I would have them ping their favorite website and then put the IP address in the browser, and everybody they would be like, "How did this number take me to this, Nike site or whatever?" So having real world examples was good. They all loved doing labs. So I would try to do less talking and more labs. We had these robotic Legos. They absolutely loved that. I mean, I saw kids becoming leaders of their group. Kids helping other groups out. That maybe not necessarily liked each other. So it was like a community vibe kind of feeling. Then I would say, hey, a lot of you guys, want to go to the NBA, NFL as athletes. I said, you can go as a data analyst. I said, when, Charles Barkley and Shaq and all them there giving commentary, they don't know those stats. There's a data analyst providing them with those stats. So, I would try to make things, real life and reachable and attainable for them.
If you were to develop a coding organization at your school, so in myself and a couple other students, we try to develop a coding organization where students would like actually come to a club and code. We didn't get a ton of student interest, so I was wondering if you could talk to what would be a good like way to go about that, creating a club or getting students interested in actually coming to that.
Well, I would say an after school program, because during the day teachers have to follow a strict curriculum that sometimes you have to cover standards and things like that where the kids may find boring. So food always helps. I would have a maybe have pizza and have it like an internet cafe. Like it's going to be pizza and tea or something like that. They may not have been exposed to, but also displaying student projects. So one idea that I had at my school was to have videos of students working together and have a screen up in the cafeteria in order to get more interest. They love playing with they used to love playing with remote control things. So we did have a robotics club that became successful, and also there was this thing called Sea Perch where we actually built a boat with Cat 5 cable and we were soldering and we used the vise, the whole thing together, and we did it on a Saturday, and most of the students that showed up that day were girls, and we were all like, yes, it's working, So for me myself, when I got into IT, my grades went straight through the roof because I love working with my hands and I love lab time. So I think that students when they're allowed to be creative without being inside of the box of a curriculum, then their creativity just grows.
I'll say the other thing to kind of look at for a resource is the Girls Who Code model.
Oh.
And they have, I mean, it has the name Girls Who Code, which is, they allow boys and girls in it. But what they do is basically each student is coming up with what problem they want to solve. And then the curriculum kind of talks them through how they can solve that problem. And they have it for, like upper elementary, lower middle school, and then they also have like a high school version. Obviously Girls Who Code has a collection of, books and that sort of thing, but the club part, it's free to start, and there's tons of resources to kind of help you. The person who starts it, the chapter doesn't necessarily need to have a coding background. They provide you with all those resources, but also I think just the way it is, it's like, what problem do you want to solve? And so I think that that's a powerful way that I think a lot of people can look around and see problems. And, especially young people, they tend to have a better view than us older folks on what problems to solve. And so this is a great way to kind of help them, with their social engagement also.
Mm-hmm.
Definitely. Yeah. Thank you.
Mm-hmm.
Well, if anyone doesn't have any more questions, we could maybe wrap up for the day. Thank you all so much. Thank you, Allison and Haroon. That was super helpful to kind of see what the TEALS program was about and to have your insight into the program.
Mhm.
Thanks
you for
again so
having us.
much. We appreciate you thinking of us.
Yeah, so yeah, thank you so much. So for the last part, we just wanted to say thank you all so much for taking the time on your Saturday to come to our conference and learn about coding. I'm sure the students will be super happy to kind of learn about these topics. So we will be in touch in the next couple of days with a survey to get your feedback on what we could do better, what we could do in the future if we do this conference again. And then also we will be collecting your email addresses and addresses to send out your Makey and your Arduino. Just a note, our ku.elevate Gmail is not currently working. It was blocked, so I will include my email in the chat. So if you have any questions or anything at all, you can just go ahead and email me and I will send it to the rest of the group. But once again, thank you all so much and have a good rest of your Saturday.
Thank you all for coming.
Yes, thank you.